All right, let's dive in. Today, we're going to pull back the curtain on one of the most advanced car factories in the world to figure out how Tesla is completely rewriting the rules for building a car. It's really a story about making things radically simple, and it all kicks off with one pretty incredible number. Just look at that, 70 down to 1. Now, what does that mean? Well, imagine taking 70 different, complex, stamped metal parts that make up the back end of a car and replacing all of them with a single piece. To really get why that is such a game changer, we first have to understand the problem they were trying to solve. For more than 100 years, building a car has always been about complexity. It's a process of just adding things together, bolting, welding, and gluing tons and tons of tiny little pieces together to hopefully make a whole. Think of it like a giant 3D metal jigsaw puzzle. You've got literally hundreds of pieces of sheet metal, and then this whole army of robots has to pick up every single piece, hold it in exactly the right spot, and then weld it to another piece. And you do this over and over and over again. You end up with this complex web of joints and seams. It's slow, it's really expensive, and every single one of those joints is a potential weak spot or just adds more weight. So this is the big question that was driving Tesla's engineers. They were thinking, instead of adding hundreds of pieces together, what if you could just start with one massive piece? Could you build a car's structure less like a puzzle and maybe more like a sculpture? And the answer, it turns out, is a big yes. The solution is called Giga casting. And the technology at the heart of it is a process that's actually been around for a really long time. It's just never been used on a scale like this. It's called die casting. Die casting is just unbelievably efficient. One engineering textbook calls it the shortest route between raw material and near-net shape. What that basically means is you're taking molten aluminum alloy and, using incredible speed and force, you're shooting it into a steel mold, that's the die, to create a really complex part in just a matter of seconds. So let's just walk through it real quick. First, you melt a very specific aluminum alloy. Second, you inject that liquid metal into the mold. Third, you hit it with immense pressure, and that makes sure every little nook and cranny gets filled and the part is super dense. And then finally, you cool it down just enough so it turns solid, you open up the mold, and pop out the finished piece. It's a simple idea, really, and it's definitely not new. In fact, check this out. This diagram is from 1849, and it shows the exact same principle at work. A plunger forces liquid metal into a chamber and out through a nozzle. So the core concept is well over 150 years old. If the idea is that old, then what's the big deal? The big innovation here wasn't inventing die casting. It was scaling it up to a size that was pretty much unimaginable before. They actually worked with manufacturers to build these colossal machines called Gigapresses, which are basically giant die casting machines that can create entire sections of a car's frame in a single shot. And the difference is it's night and day. On the left, you've got the old way. Hundreds of parts, all that complex robot welding, and a heavier structure. Then on the right, with Giga casting, it's one or two big parts from a single injection. It's lighter, it's stronger, and it's so much simpler. But believe it or not, that's only half the story. See, at the exact same time that Tesla was revolutionizing the car's frame, they were doing the exact same thing to its power source. They were turning the battery pack itself into a core part of the car's actual structure. So in the past, Tesla used these smaller 2170 battery cells. They were bundled up into modules to keep them safe, and then the modules went into this big case, which was then bolted into the car. With the new structural pack, all of that changes. They use a bigger, much more efficient 4680 cell, and they just get rid of the modules altogether. The battery pack isn't just cargo you bolt in anymore. It is the floor and the central structure of the entire car. And this 4680 cell is really the key to making all of this work. It's not just bigger, it was designed from the get-go for super efficient manufacturing. Tesla developed this new dry coating process for the electrodes inside, and that is a huge deal because it gets rid of the giant, power-hungry ovens and all the nasty solvents used in traditional battery making. It promises to slash costs and the factory footprint. This quote really just says it all. The individual battery cells, all arranged in this neat grid, are now literally part of the car's skeleton. The top of the battery case is the floor you put your feet on, the seats bolt right onto it. It's just an incredible level of integration. So how does a pack of batteries make the whole car stronger? Well, this engineering diagram shows a really simple principle. A flat beam can bend pretty easily, right? But if you add a rib to it, like in the bottom diagram, suddenly it becomes way stronger and resists bending. The internal grid structure of the battery pack, with all of those cells, acts like thousands of these little ribs, giving the whole chassis this immense rigidity. Okay, so now let's bring these two giant innovations, the Giga casting and the structural battery, together. This is where you see the real genius of the whole system. You're creating a car's main body with just a few key pieces, almost like a giant model kit. And the result is a car body built from just three main components. You have a front gigacasting, a rear gigacasting, and connecting them right down the middle is the structural battery pack. This diagram here just shows you how complex the engineering is to make even one of these castings, making sure that a single perfectly balanced part can replace dozens and dozens of smaller ones. It all just boils down to this simple equation. Two huge castings plus one structural battery pack equals the entire main structure of the car. Hundreds of parts and processes are just wiped out and replaced by three. And here's why any of this should matter to you, the driver. That lighter weight? It means more range and better efficiency. Putting that heavy battery pack so low as a structural part creates an incredibly low center of gravity, which gives you that amazing go-kart-like handling. Fewer parts and simpler manufacturing? Well, that opens the door to lower costs down the line. And a more rigid, integrated structure is just fundamentally safer in a crash. And make no mistake, this isn't just some clever one-off trick. Industry watchers are already calling this the Giga casting megatrend. It's a signal of a fundamental shift in how cars are going to be designed and built across the entire industry for years to come. Which really leaves us with one final big question. This new process is simpler, it's stronger, it's lighter, and it's potentially cheaper. So if you can now build the core of a car with three main pieces instead of 300, what's to stop every other car company from doing it? We might be looking at the future of how all cars are made, right here.